Hi, in this session I'm going to talk to you about inequalities. So inequalities, they look like this right here. 3 is greater than 2, that says. This says x is greater than 1. 11 is less than 29. Okay, so you might want to learn about how to solve inequalities, what they mean, how to use them, and so on. So let's see where this goes, and I'll talk to you about that. Okay, so first of all, I've entered two things in Mathematica. Now, the first, I'll get rid of the second one, and I'll just press Shift Enter. So basically, if you enter 4 is greater than 5, well, we know that's false. So what will happen is if you press Shift and Enter, you will get false, fortunately, because that's correctly false. All right, now, what about 5 greater than 4? That should be true, right? Yes, true. So these act as a question when you just enter them and press Shift and Enter. All right, now next, what about greater or equals to? How do you enter that? Okay, 5 greater. Notice I put the greater, and now I will write equals. You see that? Okay, and then I will press 4. And look at what happened. It became the symbol that we all know as greater or equal to. All right, now 5 is greater than 4. So it is greater or equal to 4. All right, Shift Enter, and it's true. All right, so that's the basics of inequalities. All right, they're really simple. But when you try to solve for x in an inequality, they can get a little bit complicated. All right, anyway, let's have a look. Inequalities arise when you're comparing two values or expressions where one is greater than or less than the other, or equal to, right? The symbols used in these expressions are outlined below. Okay, so I've got a little table saying what the meaning of these are. So I'll read that to you. All right, so this symbol here, less than, is less than. For example, 2 is less than 3. Okay, is less than or equals to. That's the next one. For example, 3 is less than or equal to 3 because they are equal. And 2 is less than or equal to 3 because 2 is less than 3. Right, now when you turn those the other way, it's just as we've already discussed. Is greater than or equal to. Okay, so these are the important symbols that we need. And of course, there's also the equal symbol, but we don't call that an inequality. We call that equality. Okay, rules for rearranging. Now, you might want to solve an inequality. Let's just think of an example. All right, 2 times x is greater than x plus 1. All right, now before I go on to tell you the rules, I'll just solve this inequality for x just to show you, well, to help you get familiar with the process. Okay, so first of all, I will subtract x from both sides, just as I would do if this were an algebraic equation. All right, now I'm going to write this in comment form, okay, because I'm explaining the calculation. All right, so I want to subtract x from both sides. So I have 2x minus x is greater than 1. Okay, and then I simplify that left-hand side, and I find that x is greater than 1. All right, so all of that is a comment. So I'll put the comment around it and carry on. Okay, now let's talk about the rules. Rules for rearranging inequalities. Okay, so our first rule, if we multiply or divide both sides of the inequality by the same negative number, then the inequality sign is reversed. Okay, now this really requires an example to get your head around. Even though it's fairly simple, let's just give an example. We all know that 4 is greater than 3. Let's press Shift Enter. Yes, true. All right, but what if we multiply throughout by -1? All right, because if this were an equation, that would be an okay thing to do, to multiply throughout by some number. Right, but not true for inequalities. Right, for example, have a look at this, Shift Enter, false. Okay, but it is true when you swap this around. Okay, So in fact, 4 is greater than 3 if and only if minus 4 is less than minus 3. Now this here is an abbreviation that's common in mathematics to mean if and only if. You often need to write in shorthand. Okay, so this is a comment. So let's turn it into one. All right, so what we're saying there is that you've got to swap around the inequality when you multiply by minus something. Okay, let's scroll down to the next rule, which says if we swap the quantities on the left and right sides, then the inequality sign is reversed. Well, yeah, that's pretty obvious, isn't it? If A is less than B, then B is greater than A. Okay, I don't need to say anything about that because that's just plain obvious. All right, next one. If we multiply by a negative number, then we must reverse the inequality. Well, yeah, we've already said that. All right, minus 3.7 is greater than minus 3.9. And if you need to view this, you can do so on the number line. All right, you draw a number line, you put these on the number line and you compare them. Which one is on the right? Well, that's the bigger one. Okay, so because of this, we multiply throughout by minus 1, and we have 3.7 less than 3.9. Okay, if we invert the quantities on the left and right sides, then the inequality sign is reversed. So, for example, 2 is less than 3, or 3 is greater than 2. Okay, but if we want to invert, as in take to the power of minus 1, we can do that, but we have to swap around the inequality sign. Okay, so 1/2 in decimal numbers, that's 0.5. That is greater than 1/3. In decimal numbers, that is 0.3 recurring. In other words, 0.3333333, and so on. Let's just calculate that. So I'll put in 1/3. All right, if I just press Shift Enter now, it'll chop it off. Let's go 50 decimal places, so you know what I mean. All right, these 3's keep going. So we say 0.3 recurring. Now we often put a little overline over the 3 to suggest that that part of the decimal expansion is recurring. Okay, now where were we? Yes, we've said that. Absolute value. So absolute value also comes up when you are dealing with inequalities. All right, let's have a look at the definition of absolute value. Okay. All right, so absolute value. Now in Mathematica, that is ABS. So ABS, for example, let's try ABS minus 3. Shift Enter, it's 3. So what it does is it takes a negative value and just gives the positive version of it. In other words, the distance that number is to the number 0 on the number line. All right, now in mathematics, it has this vertical bars on either side of the thing you're taking the absolute value of. So we can write this as a piecewise function and say that the absolute value of x is equal to x if x is greater or equal to 0. So in other words, a positive number or 0, then absolute value of x is just x. But if x is negative, then absolute value of x is minus x. All right, so have a look. This is true because we can ask the question, is this equal to minus in brackets minus 3? All right, let's press Shift Enter. True. All right, so that is exactly applying this rule here. I should say that the absolute value also works for imaginary numbers and complex numbers. So let's also try to calculate. Let's see, ABS, and now I'll go 3 plus the square root of minus 3. Okay, now I want to take the absolute value of that. Well, this is not a real number. It's a complex number because we're taking the square root of a negative number, which makes this part imaginary. Okay, so this is what we would call root 3 times I, where I is the square root of minus 1. Right, so it has a real part and an imaginary part, and we can view this as a point in the complex plane. All right, so as a point in the complex plane, we might view this as the point 3, and then root 3 in the imaginary direction, right, and 3 in the real direction. So we would view it as a point like this. And now when we take ABS, well, we can do that in Mathematica, but what is it known as mathematically? It's known as the modulus, right? Modulus. Argument is the angle from the real axis, the positive end of the real axis. Okay, so I press Shift Enter. I got true for this first question, and then we asked to take the modulus of this complex number, and well, the distance of that point to the point 0, 0 is 2 root 3. All right, and then this last one is just repeated this in mathematical notation. Okay, so that's absolute value. All right, now let's have a look at an example here where we are asked to solve the inequality, the absolute value of x is less than 4. Okay, now, as I recall, you can also do this with complex numbers, all right, because of what I just said. But let's consider the cases, right? That's the most elementary way to think of it without going into too much detail about complex numbers. All right, so let's write in comment form. All right, to solve, and I'll just write this, all right, because I'm only writing a comment. To solve this, separate cases, all right? And again, this is only one way to do it, all right? Separate cases. So we'll say case 1. All right, what did we say? Let's first suppose that x is greater or equal to 0. So if x is greater or equal to 0, now I can use Mathematica's fancy way of turning greater and then equals into greater or equal to, right? Because that's handy here. All right, so if we have this, then the absolute value of x is equal to just x. Now what I'm doing is I'm just looking at the definition here. Just taking the definition. All right? And so what does that mean? Well, when we're looking at this inequality, so we'll say, so this becomes just x is less than 4. All right? So that's that case, x less than 4. Solved, all right? But there's another case. All right, that other case is if x is negative, all right? So case 2, if x is negative, then what we have is absolute value of x is equal to minus x. So I can copy now. This becomes, in this case, this becomes minus x is less than 4. All right, but remind yourself that we need to solve this inequality for x. So multiplying throughout by minus 1, we have to turn the sign of the inequality around. I mean, the order, swap it around. Okay, so x is greater than minus 4. All right, so I have not really read what I've got here earlier, so let's have a look. All right, so this says we want the values of x that satisfy both x greater or equal to 0 and x less than 4. All right, so we should have said that before we moved on to the second case. Okay, so let's write but. Now, I think you're not supposed to start a sentence with but sometimes in mathematics it's just natural. All right, so where were we? 0 less than or equal to x, because that was part of that assumption. and we deduced that x was less than 4. Oh, but this, so this, okay, sure. Case 2, x negative. All right, so we've solved the case x has to be greater than minus 4 in the case that it's negative. All right, but so we've got a but because we assumed that x was negative, right? So we've got to combine that with our conclusion. So 0 greater than x, which is greater than minus 4. Okay, so we came to two conclusions. Now, how do we put those together? All right, so our first case gave us this, and the second case gave us this, all right, as our two possibilities. Now, notice how they match up, all right? So, let's say putting these together, what we have is x is greater than minus 4, but less than 4 in that case. All right, and that makes sense if you're just thinking about the absolute value and distances from the origin. That would say that the distance of the point on the number line from the origin is less than 4, and this is exactly what we should get. All right, so that's how to think about it logically. All right, now that we've done that, let's ask Mathematica to solve this. Now, I'm not sure if I remember the commands for this. I'll just try. It might be reduce, all right? So I'll say solve, first of all, ABS, x less than 4, and I want to solve for x. Let's try. Okay, so no surprises. It's the wrong command for that, so it might be reduce. Let's just try, and if this fails, I'll look in the help file. Okay, sure. So it did work. So reduce works, but maybe it's not exactly what you want to see. All right, now first thing to notice is that we've got IM for imaginary and RE for real. So it's thinking of this function in a complex sense. All right, so perhaps that's not ideal, but this gives opportunity to discuss what this double and means. All right, this simply means and. All right, so we would read this as the real part of x is between 4 and minus 4, and the imaginary part of x is between this number, sorry, this whole number here and this whole number here, as in not integer but entire thing written. Okay, but that's not exactly what you want. So let's just go into the help file, documentation, put it over here so you can see it, and I'm going to ask, I'm just going to write inequality. Inequality. Okay, inequalities. Let's take a look. Now, reduce. Okay, we've seen reduce. Is there another one? I'm trying to think at the same time. Is there another function? Let's try simplify while we are at it. Simplify. Okay, don't know. X is not in memory, is it? Clear all X. Okay, there's one more thing that we should look at. All right, so it seems like I couldn't find the right function to solve this inequality in a way that was satisfying. It's probably in there, right? But I just can't find what I'm looking for. But there's one more thing to do with this. It's called region plot. So let's go back and select this. I don't know where it's gone now, but I remember region. Region plot. Now let's just first of all try a simple one. -4 less than x less than 4. We need to specify the range. Okay, so x going from, say, -4 to 4, for example. Do I need to include a y value? Okay, well, it's given the entire thing. So what if I just say yeah, look, this is not exactly what I was hoping for here, but region plot is very useful because it's very useful for when you want to plot solutions of an equation satisfying something. Let's see if I can give you a better example. So x squared plus y squared less than 4. So this should be the inside of the circle with radius 2. All right, yes, and it does do that. It shades in the circle. Okay, so yeah, this is a very useful built-in function for visualizing the solution to inequalities. Okay, so I'm just going to add to this, and I'm going to say and y is positive. All right, so I put in two conditions, two logical conditions. Press shift enter, and now what do we have? We have the upper half of the plane but inside the circle. All right, so you can see the utility of this built-in function. Okay, coming back to this, I found what you need to do in order to solve this inequality with Mathematica and get the right answer. Okay, so what you have to do is also state that the imaginary part is equal to 0. All right, because it's thinking of this as a complex function. All right, even though you're thinking of this as a real number. So what you have to do is just say this is a real number. All right, by saying that the imaginary part is equal to 0. And that does the job, as you can see right down here. Shift and enter. And you'll get x between -4 and 4. Okay, so that does it. All right, see you next time. Bye.